Hi YouTubers, this is the Celtic Engineer, and today we are going to talk about the user interface in the example code for the SF-1 temperature sensor, which is made by Celtic Engineering Solutions and is available for sale on their website and also on Tindy. There'll be links below. So let's go over how this is set up. So we're using the ground is on the bottom, and then we're using the 5 volts to power this rail. There's jumpers that go around here. These are our 2 pull-up resistors for the I2C, because this is an I2C device. You'll notice that we're using the default setting because all of the jumpers are open. There are 5 wires that connect to the temperature board. The first one is the 5-volt power. The next one is SDA SCL, that's for I2C. The white wire gets connected to pin 2 in the example code, and what that is an alert or an interrupt, and then finally ground. So let's go ahead and switch over to the interface, and we'll talk about, well, this is the code, and we'll go ahead and upload the code to the Arduino and watch our serial monitor. So you can see it says that it's the temperature sensor SF-1, and there's 5 things, or actually 6 things that you can do. H will always return this menu. So what we're going to do is first we're just going to read the registers the way they are. We'll put a number 1 in here, and it talks to the device, and it says that it'll tell you the hex numbers that are in each of the registers, and then it gives you a rough calculation on what the temperature is. So what we'll want to do is we'll really want to start by configuring the device, and configuring the device is done in kind of subroutine number 4 or option number 4. The code is very simple and annotated. You shouldn't have a hard time setting it up. So here is incoming byte is number 4. Then so when we give it a number 4, it'll jump to this code. And what we're going to write in here is we're going to write to the configuration register, and all we're going to do is we're going to tell it that we want it to have its highest sensitivity or 12-bit resolution. There's a lot of other things that you can do, and you can read in the data sheet how to add those, what things you can configure this for, and you can just augment this field right here and set the different bits that you want in order to configure it the way you want. But we're going to just keep this simple and do a 12-bit read. So we'll go ahead and just to configure the device, we enter 4, hit return. Configuration register has been updated. We can go ahead and read the register again. You'll probably see that on my screen it hasn't changed very much. On yours, the first time you do this, it'll probably change because it won't have set those registers, and I've been playing with it all morning. Do notice that the resolution changed from 19.5 all the way down to its highest resolution, so we're getting a nice resolution on the temperature. We can go ahead and read by entering number 5, and it will tell us the temperature in both degrees C and degrees F. There's some other things that you can do. You can set the temperature limit, and you can set the hysteresis. And this has to do with the temperature limit in the code is set to 85 degrees C with a 5-degree hysteresis, and that hasn't been set yet. We can go ahead and do that in a moment. So if you enter in number 2, it'll just tell you that the temperature limit has been updated. It's hard written in the code, but you can easily go into the code, go into number 2, and you can see where the temperature is set, temperature limit is set to 85 degrees C, and you can change this to anything that you would like within the range, operating range of the device. The hysteresis is set the same way. You enter number 3, hit return, and it just tells you that it's been done. I didn't add, because this is not about code, I didn't go in and write a user interface for you to be able to on the fly put in whatever code, whatever temperature or hysteresis you want. I'll leave that to you to do. What we can do is we'll go down to number 3, and you can see here is the hysteresis, and it's set to 5 degrees. So what this does is there's 2 modes when you configure this. You can configure it as in comparator mode or interrupt mode. Each one of these, if the temperature goes above your maximum limit that you've set, you will get an interrupt on this white wire going to pin number 2. And what the difference is that in comparator mode, it will always be it'll always be in alert mode when it's outside of the temperature range, and it will only clear that when it comes back into range. In interrupt mode, if you read the register, it will clear the interrupt. So, and then the window can get kind of cluttered in here. You can get lost where you are. Again, if you just type in H, hit return, it'll bring you back to the main menu. You can even clear this out and then bring back the same main menu. I hope you find that useful. I hope you have fun with the temperature sensor board. Check out our other boards in the Solstice family, and I enjoy playing with the board.